Hi, Max. Me again. So, long time no see. I actually ended up looking at this problem in two different ways. I think it caught me sideways the first time around because I was trying to figure out a way to do it without giving you what you don't like, which is some algebra. You said you weren't a fan of quadratics and things like that. So I was like, well, maybe there's just like an easier way that your teacher's going about this so you haven't had to do it in a while. But I couldn't get around it without squaring something. So what I went ahead and did is I did, again, this problem in two different ways. I used the Pythagorean theorem to produce this line here. And then I used another technique where I expanded the diagram to make a full circle and then turned that radius into a diameter, which is just a special type of chord. So then I just had two chords sort of running into each other. And that's probably the way you would go about setting up the problem within the context of this chapter, since you're studying secants and chords and angles formed by those items. So I'm inclined to think that this line here would maybe grab you. But again, we're looking at some squaring. So let's just get to it, shall we? So if we expand this diagram to make a circle, I just drew the other side of the circle, made it a radius. And then what we're learning is the fact that, the product of this segment here and then this segment here is equal to the product of, this segment here and this segment here. So I just went ahead and I multiplied those things together. The green segment times the yellow segment, that's pretty easy. That's where this 130 squared comes from over here on the side of my screen. I'll shrink that down a little bit. So yeah, if you take 130 times 130, obviously that's 130 squared. To get the length of the red piece there, that's obviously 70, so that wasn't too bad. And then to get the length of that blue chord right there, if we know that the radius is always just r, and then the other radius was still r, but they had the little piece of 70 there, we could write that other side there as just, basically, r minus 70 plus r then again. So that's the other side of that chord or that diameter right there. So I hope that explanation made sense. But then, we got a little bit of algebra to do. So I went ahead and combined my terms. R and R is 2R. And I brought down my minus 70. And then I went ahead and I distributed the 70 in to the parentheses there. So I got my 140R minus my 4,900. And then I added 4,900 to both sides, which was 21,800 right there. And then I divided both sides by 140, and I got about 155.7. The wonderful thing about having flexibility in problem solving and doing problems in different ways is that I was then able to use the method I didn't want to use at first with you, the one that was embedded in the Pythagorean theorem, to attend to my precision and check the accuracy of my response. So I did end up grabbing up the quadratic that I wrote up here, a little throwback to Algebra 1. That again did just come from the Pythagorean theorem, and I did the Pythagorean theorem on this little triangle right in there. So we have a side squared or a leg squared, that's 130 squared, and then this piece here again is that r minus 70, because if this is your whole radius, we have to take 70 away to get this little piece in here. So I have 130, and then add r minus 70 squared, and then that would be equal to the hypotenuse r squared there. And then expanding the polynomial that results on the left gives me that 16,900 plus r squared minus 140r plus 4,900. Luckily, the r squareds go away. They don't hang out for very long. I end up with almost the exact same equation as on the right. So I got, again, about 155.7 as the response. So I certainly hope this helps you. Once you're my student, you're always my student, so you can feel free to email me if you have any questions about it. Happy to help you out, Max. You take care. Bye-bye.